Welcome to an example of classifications of functions such as one-one function, onto function, bijections, and invertible functions. Show that the signum function is neither one-one nor onto. What is signum function? Signum function is defined like this. F of x is equal to mod x upon x when x is not equal to 0 and f of x is equal to 0 when x is equal to 0. Let's try to understand this definition with the help of an arrow diagram. Set of real numbers to set of real numbers. The images. Whenever x is not equal to 0, this is the rule to be followed. Say for example, I am taking x is equal to 1. When x is 1, mod x upon x is mod of 1 upon 1. Yes, 1 upon 1 is equal to 1. So the image of 1 will be 1. Let me take another number x, say 3. Then mod of 3 upon 3. Mod of 3 is 3. 3 upon 3 is 1. Oh, the image of 3 also is 1. Let me take another number, say 4.1, a decimal number. 4.1 modulus is 4.1 upon 4.1. So 4.1 upon 4.1 also is equal to 1. So images of these positive numbers equal to 1. All the elements, all the positive numbers I tried, many positive numbers I tried, every time I am getting the image 1. Now let me try a negative number, say minus 3. Modulus of minus 3 is plus 3. Modulus of minus 3 upon minus 3. X is taken as minus 3. Modulus of minus 3 upon minus 3. So numerator is plus 3, denominator is minus 3. So its value will be minus 1. So image of minus 3 is minus 1. Try another negative number. Say minus 4. Modulus of minus 4 upon minus 4. Modulus of minus 4 is plus 4 upon minus 4. Plus 4 upon minus 4 again minus 1. So all these negative numbers are giving me the image minus 1. So the two images we got 1 and minus 1 so far. But let me see if x is equal to 0. See, we are told when x is equal to 0, don't use this rule. The reason is obvious. When x is equal to 0, the denominator goes 0 and this goes undefined. So the function says, when x is 0, you take the image directly as 0. That means, when x is 0, the image is 0 directly. So 0 is also an image. So ultimately what happens is, we may take the domain as complete real number. Complete real number as the domain. All x values we use to calculate. But the images are only 3 numbers. So the range is minus 1, 0, 1. A limited set, only 3 elements. So this function can be now rewritten as this also. Whenever x is a number more than 0, all positive numbers, their image will be 1. And whenever x is less than 0, all negative numbers, the image will be minus 1. Minus 1. And when x is equal to 0, the image is 0 itself. So this is again same as the signum function. Signum function may be written like this or like this. Now, we need to check whether this function is one-one function. So, before that, let us look at the graph of this function. How do we draw its graph? We have the table values. Minus 3 is image is 1, minus 1. So minus 3 minus 1, minus 2 minus 1, minus 1 minus 1. All these negative numbers y value 1, minus 1. 0, 0, yes 0, 0. And all positive numbers y value plus 1. This table values let us plot on a graph. That gives us 1, 1, 2, 1, 3, 1, 4, 1, etc. But 0, 1 should not be taken. That is why this blank. And minus 1, minus 1, minus 2, minus 1, minus 3, minus 1, etc. Again, 0, minus 1 should not be used. When x is 0, use it as 0 itself. This is the graph of signum function. Now, let's see whether it is a 1-1 function or onto function. I go by some counter example. Because here you observe number 2 and 3, two values x1 and x2 we take unequal. Two elements 2 and 3 unequal, but we have already noticed 2 and 3 have equal image. The image is 1 itself. So f of 2 is 1, f of 3 is 1. The images are equal. So distinct elements got same images. Distinct elements have equal images, which is against the definition of one-oneness. For a function to be called one-one function, distinct elements should have had distinct images. Hence it goes against the definition of one-oneness. This is treated as a counter example, so we say the function is not one-one function. Now for onto function. From the codomain I take, for example, I take y as 4. Say take y as 4. Now you see, is it possible to have an x in the domain whose image is 4? Image is never 4. Image of no x is 4. So, there is no x in the domain whose image could be equal to 4. It goes against the definition of onto function. What is onto function? Onto function is that function in which for every element y taken in the codomain, there should be an x available in the domain whose image is that y. And we took number 4. And number 4 has no x in the domain whose image could be that 4. So it goes as a counter example. Hence, we conclude that this function, the signum function, is not onto. So, signum function is neither 1-1 nor onto.